Recording. Glad you guys are here today. Noel online and the rest of you folks here with us. So let's see, y'all. Let's see. Here we go. Weekly activities folder. So we are in week 13. Man, we're wrapping up the semester. So y'all, I'm not sure if you guys are aware of this, but semester is 16 weeks long. So we got, we got 3-4 more weeks to go. You know what I mean? After this week, we got 3 weeks to go, right? So we're winding down. So let's see, y'all. Okay, so let me go ahead. I got the notes and all the kind of good stuff, what we're doing this week here. So let's see. Okay, this is all the general info. I think you guys know that already. Let's see. So today, what we're going to do, we're going to go over 6.1, about half of 6.2. 6.1, y'all, that homework will be due Wednesday the 27th. So I want you to know this. Today is the 18th, right? So if I pull up my calendar real quick, Wednesday the 27th, that's when the homework for 6.1 is due, okay? I'm making it due then because really, I'm going to go over 6.1 today, like I said, y'all, in about half of 6.2. Really what I want y'all to do between today and, say, Wednesday is make sure that you've been working on that review for test 2, okay? Today I'm not going to cover all of 6.2. I'm just going to do about half of it. That homework won't be due until Monday, May the 2nd. Okay, so that's 2 weeks from the night. Okay, so 6.1 is due in about a week and a half, and 6.2 is due in 2 weeks. Okay, so anyway, today we'll go over 6.1, and like I said, about half of 6.2. Wednesday, guys, all we're doing is just reviewing for the test, right? So let's do this. Let me go ahead and scroll up here, because right here I have the notes for 6.1. Okay, so let's talk about 6.1 and figure out what it is we're doing here, okay, y'all? So in 6.1, guys, we are finding the area between curves. So if you remember, guys, the other thing I want to mention is some of y'all did point out that I had the deadline for 5.2 messed up, so I fixed it already. Okay, so 5.2, I don't know why I had to do it 10 a.m. It was just a little brain fart. But anyway, it's fixed, okay? So y'all, when we were doing 5.1 and we were first starting to talk about integrals and stuff like that, I'm just going to kind of do this a little bit on the side here. And, we had a curve that looked something like this, and we started doing those Riemann sums where we started saying, look, let's take little rectangles, right? And we were doing little rectangles like this, like that, so on and so forth, right? And we were kind of playing this little game where we're finding the areas of each of those rectangles, and that would approximate the area underneath the curve, right? So when we're basically finding a definite integral, we are finding the area underneath the curve. So what 6.1 talks about is, well, how do I find the area between two curves? Well, if we're going to find the area between two curves, y'all, if I didn't have, say, this curve here, and I wanted to find the area between from A and B for this top curve, we would be finding that area right there, right? And if all we really wanted was the middle, then we could then say, well, look, how about if we find this area, and if all we're looking for is the middle, what do you think we're going to do with those two values? Subtract them, right? We're just going to subtract those two areas. And if you notice right here, there's our subtraction, right? Because that's how we find the area underneath the curve. So when we're trying to find the area between two curves, y'all, the one thing that's really important here, I'm going to call this, I know you're using F and G. I'm going to use a capital T and a capital B. And again, if you remember, y'all, back, man, I don't know, what are we now? We're in April, so this is probably back like in February. We talked about the quotient rule. We use the top function and the bottom function. We need to know which is our top function, because the top function is going to be the graph that's above, and then the bottom function is going to be the graph that's a little bit lower. So we really need to know which is going to be our top function, which is going to be our bottom function, okay? All right, so let's take a look here. Let's say we can't figure out some of this stuff, and here is my first problem. So what we want to do is we want to find the area of the region between the graphs y equals 12 minus x squared and y equals negative 5x plus 6. Okay, so a couple things we can do here, y'all. I'm going to grab my calculator here and turn this guy on. Okay, I'm going to clear everything out. I'm going to go to my y equals, and I'm going to do 12 minus x squared. Okay, that's my first one. And my second graph is a negative 5x plus 6. Okay, there it is. And I want to go ahead and graph those. I just want to see what it looks like. Okay, so look, there's my 12 minus x squared. There's my minus 5x plus 6. Okay, so I'm going to try to mess with the window a little bit. Let's see. My x minimum, I don't want to go that far to negative 10. I don't know. Let me try negative 5. My x max, I don't know. I'm going to try to go to 6. Go by ones. My y min, I'm going to go to negative 1. My y max, I'm going to actually put that up to 12. And let me come back to the graph. I'm just trying to mess with it a little bit to see if I can kind of get a picture of what's happening here. Okay, so y'all, let me ask you a question. Do you agree that this one here is my 12 minus x squared? Because don't x squared graphs, aren't those parabolas, right? Okay, so wouldn't my top function be the 12 minus x squared and my bottom function be my negative 5x plus 6? Because remember, I'm going to, just like we did over here earlier, or we looked at the picture. Come back over here, and let me look at my picture. I got to take the top function minus the bottom one, right? So when I look at my graph here, y'all, come back to this too. Okay, there. Get this guy back. There we go. So my top function is going to be that 12 minus x squared, right? Okay, so this is what we're going to do now. Come back this way. Okay. So what we want to do is we're going to find, the integral of 12 minus x squared minus a negative 5x plus 6 dx. Okay. And so let's see if we can simplify some stuff here. So look, let's see. That's 12 minus x squared. That is a plus 5x and a minus 6. Okay. Dx. Okay. So guys, if I just start combining like terms, negative x squared plus 5x, a 12 and a minus 6 should give me a plus 6. Okay. Dx, right? So all I've done is just kind of, subtracted the 2, and then we are combining our like terms, right? Now, y'all, one thing we need to figure out, and I'm going to scroll back to the concept back here. Do you see how they're integrating this over the interval from a to b, right? Those are my limits, right? I need to find my limits, okay? I need to find the limits on where we're going to integrate. So again, I want to point something out. If I come back and I look at my graph, do you guys see how the graph intersects right here? And then there's probably another point somewhere down here where they intersect as well, right? Because I can see that this is a line, right? If I were to kind of, I don't know if it lets me, it should let me trace it somewhat, right? If I keep scrolling down. It's not doing it. But anywho, let me zoom out, maybe number 3. Okay, so you can see, there you go. You can see it intersects right here, and it intersects right over here, right? What we need to do, y'all, we need to find those points where they intersect, okay? The easiest way we can find those points where they intersect is we set these two functions equal to each other. We want to know when are they going to be equal, okay? So look, I'm going to do that over here on the side. I'm going to say, when is 12 minus x squared equal to negative 5x plus 6? All right, this is going to help me find my limits of integration. So let me write that up here at the top. Okay, So, y'all, if it's cool with you, I'm going to move that x squared over, and I'm going to move this 12 over. So when we move the x squared over, it becomes a positive x squared. I still have a negative 5x. I have a plus 6, but when I move the 12 over, it becomes minus 12, right? Because my signs are changing. Okay, so now look, we have 0, x squared, minus 5x. What's a plus 6 and a minus 12? Negative 6. Okay, so y'all, what we're going to do here, we're going to factor this thing out, right? And we've gotten pretty good at factoring because we've done it a few times already. Remember what it is we're looking for here, y'all. We're looking for two numbers that multiply to a negative 6, but they need to add up to a minus 5. Almost. Hold on, remember, they need to add up to a negative 5 and multiply to a negative 6. Could we go negative 6 and positive 1? Yeah, so guys, look, this is always one that it always throws everybody off. If we go negative 3, negative 2, we end up with a positive 6, right? And we're trying to get a negative 6. So that's why we can't do the 3s and the 2s. Okay, so anywho, when we set each value equal to 0, everybody agree we're going to get x equals 6 and a negative 1? Okay, so those right there, y'all, are my limits of integration. So all we're going to do here, y'all, we're going to put a 6 up here and a negative 1 right there. Okay. All righty. So now let's see if we can find the antiderivative of this thing. Question number 1. Anybody know what is the antiderivative of a negative x squared? Give me a hint. It's going to be negative. Yeah, negative x to the third over 3. Good. What about the antiderivative of a plus 5x? I'll give you a hint. It's going to be a 5 there. 5x squared all over 2. Very good. Okay, what about the derivative of a 6? Or antiderivative. Very good. 6x. Excellent. Okay, y'all. So remember, we're evaluating this now from 6 to negative 1, right? Because it's a definite integral, right? So remember, indefinite integrals, y'all, we do have to use the constant of integration. Indefinite integrals, we need to use the constant of integration. Definite integrals, we don't have them, right? Because they're going to cancel each other out anyway. Okay, so y'all, if I was doing this problem here, probably my suggestion would be come back, turn this guy on, let me go to my y equals, and let me do a negative. Let's do it like this. Okay, so I'm probably going to do it like this. 1/3. Oops, I'll do a negative 1/3. Negative 1/3. X to the third plus 5 over 2 x squared, and then a plus 6x, like that. So I got a negative 1/3 x to the third plus 5 over 2 x squared plus 6x. Okay, so I'm going to enter that in, and then I'm going to go ahead and quit that, and I'm going to do my y bars. And the first time I do this, I'm going to evaluate this at, what, 6? 54? Okay. So we got 54 minus, we're going to do the same thing again, except now we're going to evaluate it at, what? Negative 1? Okay. Negative 19 over 6? Okay. And so now, don't these become positive now? Because it's minus minus? Okay, so then if I just add 54 to that, so let me go like this. 54 plus 19 over 6. Okay, it's going to give me that. And if I do math and convert it back to a fraction, I'm coming up with 343 over 6. That's what I'm coming up with. Anybody else coming up with the same answer? Yeah? 343 over 6. We good? Yeah. So right here, y'all, we're going to write in 343 over 6. And y'all, when you're doing this in on my open math, I'm not certain that it's going to, if you enter in a decimal, are you going to be okay? Probably. I mean, you all said it hasn't been too picky, right? So if you do, the only thing is, guys, I'm just curious, when you do something like this, how many decimal places is it like, I mean, have you ever put like one decimal place and that's not good enough? It's two? Okay. So yeah. So again, you have some options here. If you want to write, 57.1667 or something like that, that's fine. If you want to do 343 over 6, that's probably good too, okay? So y'all, in doing these problems, when we're finding the area between the two curves, we got to find the top function, we got to find the bottom function, so we know which ones to subtract. The other thing we need to do, we need to find the limits of integration. And the way we find the limits of integration is we just set the two functions equal to each other, okay? And then that'll tell us what the limits of integration are going to be. John, you got a question? Unit squared, yeah. And it's not asking you for any kind of units here, but area is always measured in square units, so yeah. Okay, so look, y'all, I got another problem here. We're going to try to do the same process. We're going to find the area of the region between the graph y equals x squared minus 19 and y equals 4x plus 13. Okay, so again, two things here, y'all. I need to find my top function. I need to find my bottom function. So let me clear this stuff out. Let me go back to my y equals. I'm going to clear this out, and I'm going to go x squared minus 19 is my first one, and a 4x plus 13 is my second one, okay? And then let me just graph them. And again, I'm not doing too much here. Okay, so just by looking at this, y'all, and I know I don't even have the whole picture, but which one appears to be my top function? If I'm finding the area, yeah, the 4x plus 13, right? Because you can see the two graphs intersect, like here's one point of intersection, here's another. We're looking for the area in here, right? So the top function is going to be the line, and the bottom function is going to be my quadratic, right? My parabola. Okay, so first thing we're going to do, we're going to integrate 4x plus 13 minus x squared minus 19 dx. So that's a 4x plus 13. That's a negative x squared. That becomes a positive 19 dx. Let's see. So we have a negative x squared. We have a positive 4x. And then 13 plus 19 should be something like 32. When we combine those numbers together? Yes. Because that's my top function, right? So remember, I'm trying to find the area right here, right? So if I'm trying to find the area here, wouldn't this be my top function? And then the x squared one is going to be my bottom function? You see what I'm getting at? So like if I were to look at that, if I were to kind of just like, sketch a rough picture of it, right? X squared minus 19 does something like this. 4x plus 13, let me just come back to my line to make sure, yeah. 4x plus 13, yeah, does, you know what I mean? Something like that, right? So here's my 4x plus 13, and here is my x squared minus 19, right? So again, if I look at the picture, yeah, there it is right there, right? It's just, I'm not zoomed out enough, you know what I mean? So like if I went to, we could go like window, let's do x min, I think we're good there. Let's go x max, let's go, I don't know, let's try 20. Y min, let's do negative 20. Y max, let's do, I don't know, positive 20. And then let's try graphing it. So look, there's that one, and there's that one there, right? So here's the line. So that's why I know my line is my top function. Does that make more sense? Yeah. So sometimes, guys, if you're going to do this on your calculator, which I think is completely fine, you just may need to adjust your window a little bit so you kind of have an idea of what the picture looks like. But that's always a good place to start off, right? Okay, so excellent question. So y'all, now that we have our integral, the next thing we need to do here, y'all, I'm just going to get rid of my picture that I drew here. is we need to find our limits of integration. The way we find the limits of integration, y'all, we just set the two functions equal to each other. Okay, so in this case, y'all, since I'm trying to solve for x here, I'm going to move the 4x and the 13 over, and I'm going to give you some advice on how do you solve, how do you know which ones to move? Okay. So look, x squared, there's a minus 4x and a minus 32 equals 0. Okay, so this is my suggestion, y'all. When you're finding the limits of integration, and one of them is a quadratic, and say one of them is a line, in my opinion, it's easier to keep your x squared being positive. So if you notice here, the x squared was positive, so I didn't want to move these people. I wanted to leave those guys alone and bring these guys over. Okay. Now I'm going to scooch back to the problem that we did a little while ago. I want you to look at this one right here. Look at my x squared right here. In the first problem y'all did, that we did earlier today, y'all, my x squared was negative, so I wanted to move them over because I want my x squared to be positive. Okay. So when I'm finding my limits of integration, I'm trying to keep my x squared so that it's positive. So if my x squared is already positive, bring the other stuff over. And if my x squared is negative, then move those pieces over, okay? All right. So y'all, we need to finish solving this thing here. So look, we can factor this thing out. X and x equals 0, okay? Let's see. Remember what we're looking for, y'all. We're looking for two numbers that multiply to a minus 32 and add up to a negative 4. Positive 4, negative 8. Question? Okay. So y'all, now when we set each part equal to 0, everybody agree we're going to get x equals negative 4 and x equals positive 8? Okay, so look, those are my limits of integration from negative 4 till positive 8. Y'all, just to give you a heads up, just so that you kind of realize what that means. Remember when we looked at our graph? Okay, right here, I don't know if you guys, can you all see my pen as I move it along this thing here? I don't know if you can see it. Oh, well, okay, right there. Right there where they intersect, that's negative 4. The other point where they intersect, even though I don't see it over here, is at positive 8. Okay, that's where they're intersecting, right? Okie dokie. So now let's go ahead and start finding antiderivatives. Okie dokie, artichokes. First question, anybody know the antiderivative of a negative x squared? Negative x to the third over 3, okay? Plus, what is the antiderivative of a 4x? What about 2x squared? Is it not 2x squared? Oh, yeah, you're right. Right? Because if we take the derivative of that, we would get 4x. Very good, okay. What about the antiderivative, y'all, of a plus 32? 32x. Very good. Okay, y'all. So remember, what we're going to do now, we're going to evaluate this from negative 8 to 4. Okay, so again, y'all, this is just, yeah, 8 to negative 4. I'm sorry, I said negative 8 to 4. So 8 to negative 4. Again, my solution here, y'all, or my suggestion here is clear all this business out. Go back to your y equals clear, clear. And I would just type in what I have there, which is a negative 1/3 x to the third, right? Plus 2x squared and plus 32 with an x. Okay, there we go. Enter that in. And then we're going to quit this. You got to quit you. And then we're going to go ahead and evaluate this from 8. So at 8, I'm coming up with 213 with a bunch of 3's after that. Wouldn't that be 213 and 1/3? Right? 213 and 1/3 minus, okay, we're going to evaluate this again at what, negative 4? Negative 4. Okay. And I'm coming up with a negative 74 with a whole bunch of sixes after that. So wouldn't that be negative 74 and 2/3? Right? And so y'all, now at this point, remember, we're subtracting a negative, so those are both going to become positive. So look, let's see, 213 and 74. 213 plus 74 is 287. So 287, 1/3 and 2/3 is another one. So wouldn't that be 288? And we found the area between those two curves, right? Okay, so y'all, again, one thing I just really want to emphasize, when we're finding the area between these two curves, really what we're doing, we're taking the top function minus the bottom one, right? So it's really important that I know which function is where. I think using your calculator to get a rough picture of it is always kind of helpful. Um, but let's take a look at this next one that I got here. It says, look, let's find the area of the region between the graphs of y equals 14 minus x squared and y equals negative 5x minus 10. Yo, this problem is slightly different from the problems that we did before because they're specifying an interval. They're specifying the interval from -4 to -2, okay? So let's see if we can figure this thing out. Hello. So first thing I'm going to do here, y'all, I'm going to come back to my calculator. Let me go back to my y equals. Let me clear this out. Let me type in 14 minus x squared. And what's the other one? Negative 5x, excuse me, minus 10. Okay, now let's take a look at the graph. Okay, there's that part, and there's that part there. Okay, so look, y'all. I need to know a couple of things. I need to know, number one, which is my top function, which is my bottom function, right? And the interval here is between -4 and -2, okay? So I'm going to do a couple of things. I'm going to come back to my window, and because I'm looking for the interval between -4 and 2, I'm actually going to do this. I'm going to let my x min be -5, and I'm going to let my x max be -1. I'm going to go one side, you know what I mean, 1 unit outside of that interval. I'm going to make my y min, I don't think I need to do it that low. Let's try, I don't know, -5. My y max, I'm going to do 15. I'm just curious to see what this is going to look like. Okay, so whoa, there's that part there, and there's that part there. Okay, so look, y'all. If I'm integrating, suppose I was trying to find, I'm going to make this up. If I was trying to find the area, say in this portion, or let's put it this way, in this portion here, wouldn't this be my top function, the parabola, right? But if I'm trying to find the area, say over here, wouldn't the line be my top function? Okay, so I need to figure out a couple things because I don't know which is my top function yet, my bottom function. Let's do this. Let's try a couple of things. Let's try setting the two functions equal to each other so we can find those limits of integration. Okay. So when we set the two functions equal to each other, quick question, y'all, which pieces should I move? The 14 minus x squared. Yeah, let's move these guys over here so that we now have a positive x squared. There's already a negative 5x. There's already a negative 10. And when I move that 14 over, it's also going to become a minus 14, isn't it? Okay, so now let's see. X squared minus 5x. Minus 10 and minus 14, y'all, should give me a negative 24. Okay. All right. So look, we're looking for two numbers that are going to multiply to a negative 24. But when I add them up, I get a minus 5. What two numbers multiply to negative 24 but add up to a negative 5? Excellent. Very good. Negative 8 and positive 3. Okay. All right, y'all. So now when we set each part equal to 0, we're going to get x equals 8 and x equals negative 3. Okay. So I'm going to try to draw a rough picture here, y'all. Here is negative 4. Here is negative 2. Right here is negative 3, right? That's right in the middle. Okay. So remember when we drew our picture right here? This right here, y'all, that's my negative 3, isn't it? Okay. So that's my negative 3. Let's see. I want to figure out which is my top function and which is my bottom function. So my line looks like it's doing something like this here. My parabola looks like it's doing something roughly like that, right? Okay, so, and we're trying to integrate this, y'all, between negative 4 and negative 2. Now, I don't necessarily know that it crosses there at negative 4, so maybe I shouldn't probably put that there. I'm going to do something right here real quick, y'all. I'm going to say negative 4 is a little bit that way. I'm not sure if it is, but it could be. Okay, my point, though, y'all, is we're trying to find the area right here between these two pieces. And we know that the graphs intersect. I know my graph is a little bit off. We'll fix it. Wasn't what I wanted to do. There we go. And what does the line look like? This right here. Okay. So we know right there that's negative 3. So let's see. Guys, if I'm trying to find the area between the two curves, if I'm finding this area here, wouldn't the line be my top function, right? Okay, so look, we're going to do this in pieces, y'all. Well, hold on. We're looking for the area between the two curves, right? So isn't the area between the two curves that area right there? Okay. So this part here, isn't my line my top function? Okay. So look, we're going to integrate the line, the top function, negative 5x minus 10 minus the bottom function, which is the 14 minus x squared, okay, dx. Okay, so y'all, since we're doing this over the interval from negative 4 to 3, or negative 4 to negative 2, I'm sorry, we're going to go from negative 4 to negative 3. Just this part right here, at that part right there, the line is the top function, okay? All right. Then we're going to add another interval. We're going to go from negative 3 to negative 2 because we want to find this part of the area too, don't we? And on this part of the area, isn't my parabola now my top function? So what's my parabola? The parabola was 14 minus x squared minus a negative 5x minus 10, right? And so between negative 3 and negative 2, the parabola is the top function. Does that make sense on how I'm doing this now? Okay, so look, y'all, we're going to do it real slow to make sure that we're good. Let's see. Integrating from negative 4 to negative 3. Let's see, that's a negative 5x minus 10. That's a minus 14, a plus x squared dx. Okay, let's deal with this part first, y'all. Then we'll jump over to the second piece. Okay. Negative 4 to negative 3. Let's see. If we combine some like terms here, I have an x squared. I have a minus 5x. What's a minus 10 and a minus 14? Minus 24. Good. All of that is my dx. Okay. Okay, so now let's go ahead and integrate. Question, y'all. What is the antiderivative of x squared? X to the third over 3. Good. Minus, what is the antiderivative of a negative 5x? Perfect. And one more time. What's the derivative of a negative 24? There you go. And we're going to evaluate this from negative 4 to negative 3. Okay, so y'all, we'll do that part in a minute because that's basically calculator work. Let's deal with the second part over here. Now remember, we're integrating from negative 3 now to negative 2, right? So we're doing this part right here. So from negative 3 to negative 2, let's go ahead and simplify some things. So look, we have a 14 minus x squared. I'm going to distribute those negatives, so that's going to become a positive 5x and a positive 10. Okay. Dx. Okay, so if I combine some like terms, I have a negative x squared, I have a positive 5x. A 14 and a 10 is going to give me a 24. Okay. So now, y'all, let's find some antiderivatives. What is the antiderivative of a negative x squared? Negative x cubed over 3. Good. What about the antiderivative of a positive 5x? Good. And the derivative of a positive 24? Okay, now y'all, I want you to notice something. Look at the antiderivative that we got here, and look at the antiderivative that we got here. I still got to do my definite integral part. Negative 3, negative 2. It's just the opposite, isn't it? And you know why it's the opposite? Because all we did is reverse them when we subtracted, right? So whatever we got for the first one, you're going to get exactly the same thing here, except all the signs are going to be different. Does that make sense? So y'all, the reason why, like, we didn't, obviously we didn't see that at the beginning, but this is the big but, right? This is the big but part now. Is when you're doing a homework problem like this, once you do this antiderivative, you already know what that one's going to look like. It's just going to be the opposite. You know what I mean? Huh? We could have, yeah. And so, but this is the thing, right? It was one of these things where we went through it and we're like, oh, okay, because look, all I did is reverse it. So when you're doing your homework problem and you get to question number 3, you're going to say, hey, look, once I do this part, I already know what this part's going to look like. You know what I mean? Okay. But we still got it. Yeah, we haven't finished yet. We're just putting the antiderivatives. Now we're going to do the evaluating. So look, y'all, this is how I'm going to do my y equals. Let me turn it on, let me clear. Okay, let me go back to my y equals, let me clear, and let me clear. Okay, so this is how I'm going to do the first one. I'm going to go parentheses. 1/3 x to the third minus parentheses 5 over 2 x squared minus 24 with an x. There we go. Enter that guy in. Okay, let's quit. Let's do our y bars. So we're going to do this twice. The first time is at what? Negative 3. And I'm coming up with 40.5 minus y bars at negative 4. And I'm coming up with 5.8 with a bunch of 3s at the end of it. But I mean, when you subtract the 2, because I did the 2. Yeah. Jennifer, you got the same thing? Okay. So 5.8 with a whole bunch of 3s. Okay. Now, y'all, when I'm doing the second part, this is how I'm going to do my y. So look, I'm going to come back to my y equals. All I'm going to do is I'm going to go second, insert. I'm going to insert a negative and another parenthesis right there. And then at the very end, I'm going to just add that closing parenthesis because all it is the opposite, right? So I just put a big negative in front of the whole deal and enter that guy in. Okay, let me quit this thing here. And now again, I'm going to go my y bars, and we're going to go from -3 to -2, right? And I'm coming up with a negative 5 point, a whole bunch of 1.6666 like that. So right here, I'm coming up with a negative 5.16667, something like that. And now what I need to do is I need to subtract these two numbers. This guy here minus that guy there. But look, y'all, minus and minus become positive, don't they? So now, if I do 5.8 with a ton of threes, and I add 5.1 with a ton of sixes, what do we come up with? 11. Okay. And there's my answer. The area between the two curves, y'all, is 11. Yeah, because it was minus. It's remember, it was really when I'm doing this here. Let's see. Yeah, I was supposed to add them together. So, are you talking about the first time, John?
Yeah, my answer is
Okay. Let me see. Okay, let me try something real quick here, y'all. Okay, so let me do this. Let me go second quit. Okay, maybe I did something wrong. Possible. Let's make sure. Let's make sure. Okay, so look, first time we're doing this, we're going from what, -4 to -3, right? Am I doing that right? Okay, hold on real quick, Bill. Just want to make sure I'm doing this thing right. Oh, I'm supposed to go -3 first, right? Am I correct? Yeah, that's what I'm doing wrong. Okay, my bad. Let me do it like this. That's probably where I made my mistake. -3, and then let me fix this here, -4. Okay, so did you come up with 5.833 the first time? Yeah, we're good there? Okay, and then let me try this again. Let me come back to my y equals. The only thing I'm going to do here, insert a negative, okay, the very top, and I had everything in parentheses. Yes. Okay, quit. Well, if you do that, that's gonna be negative, but these now have to become positive, don't they? So all I did is I just said, look, let me keep it like this. You see what I'm doing? I'm doing this here, and I'm saying the way I'm gonna do the second part is I'm just gonna put a negative there, right? Does that make sense? Yeah. Okay, so let me make sure I'm doing the second part right. Let me see. So I'm gonna go y bars. Let's see. I need to go from what? -2, -2 minus y bars to -3. Okay. Yeah. Okay. And then don't I need to add those two numbers together? And that's where we came up with our 11. But no, aren't we adding them? Because look, didn't we have this? But when we did this here, aren't we adding the two integrals? Because aren't we going from here to here? So look, y'all, we're doing the whole integral, right? But we're breaking it up in pieces. We're saying we're going to integrate from here to here, and then we're going to integrate from there to there. So we're adding those two together, right? And that's why I'm coming up with 11. Yeah, I think what I was is when I did this part here, I did my numbers in reverse order. And that's why I have like another negative and I got a little off there, but I'm really adding the two numbers together. So yeah, we're adding those together and there's my answer, yeah. Okay. So again, y'all, when we're doing this problem here, we're basically breaking it up into pieces because one function is not always the top function over that specified interval, right? And the only reason we had to do that here, y'all, is because they gave us a specified interval from -4 to 2. So part of that interval, one function was the top function, and another part of that interval, the other function became the top function, right? So that's why we had to kind of fix what we did there. Okay. All right, so y'all, I do have one more problem here, and we are finding the area enclosed by the graphs of, let me clean this up here so we can see, x equals y squared and x equals 9 shown below. So y'all, when I saw this problem, this was my first thought process, okay? My first thought process was take this graph and rotate it. And if we rotated it, yeah, it's the AC. It just gets really, really, really loud. Okay, if we rotated it, wouldn't this be y equals 9? And wouldn't this be y equals x squared? And all I'm doing, y'all, is like if I could go to the board and I could, or go to the TV, right? And I could like put my hand on the picture and then just rotate it 90 degrees to my left or counterclockwise. Wouldn't that basically be what we have, right? And what I'm trying to do is I'm trying to find the area between the two curves, right? Okay, so now first thing we're going to do, we need to find the points where they intersect, right? So we need to find our limits of integration. We need to find this point here and this point here. Okay, remember how we do that, y'all? We just set the two functions equal to each other. So 9 equals x squared. Guys, I'm going to move the 9 over. Okay, now we probably haven't factored one like this in a really long time, or maybe ever in our class, but this is what we call the difference of squares. When you got the difference of squares, meaning you only have two terms, and they're both perfect squares, you're going to put an x here and an x here. What two numbers gives you 9? One of them is negative, the other one is positive, okay? You can think about it like this, y'all. When we're doing the little trick, do you notice how there's no x term here? We could say the number in front of that is 0. So what two numbers multiply to -9 and add it to 0? Well, -3 and +3, right? Okay, so we're going to come up with two answers. One is 3 and the other one is -3. Okay, so now let's go ahead and integrate. We're going to integrate from -3 to +3. We're going to take the top function. You guys agree the top function is the line y equals what? 9. Minus the bottom function is the x squared, okay, with our dx, right? Okay, so now all we have to do here, y'all, find some antiderivatives. What is the derivative of a 9? 9x, right? Good. Minus, what's the derivative of x squared? We've done that already. -x to the third over 3, again, from -3 to +3, right? Okay, so that y'all, all we'll do here, again, we'll come back one more time. Let me turn this guy on. Let me clear all that business out. Let me clean all this business up here. So we got a 9x minus, I'm going to do it like this, 1/3 x to the third. There it is. Okay. And okay, so now that we have that, let me quit this. Go back to my y bars. Okay, so we're going to do this from 3. minus y bars again at -3, right? Okay. And I'm coming up with 36. And again, all I did, y'all, is just enter that function into my calculator and plug in my numbers, and we come up with 36. Are we good? Anybody else coming up with 36? You got a 36? Okay. So y'all, look, it's 1:21. Let me stop recording here because that is 6.2. So let me do this real quick. Let me go ahead and stop.